Alright, let's solve for the reactions for this beam. We have a rocker support here at point A, pinned at C, and then fixed at B. We can idealize this support as a roller support because this will allow the horizontal movement. Now, first thing, whenever we have internal hinge or pin connection at beam members, we always separate the free body diagram from that point. At point A, there is a roller support, so only vertical reaction, AY. The pin connection is able to transfer only the normal forces and the shear forces CY. The same point, section AC, and then section CB. So if we draw the normal forces towards right and then vertical shear at point C at left section, then it's going to have equal and opposite internal forces that is transferred to section CB. At point B it's fixed, so we are going to have three reactions: vertical, horizontal, and then moment at B. Let's look at the external loads applied. In section AC there is a uniformly distributed load of 4 kilonewtons per meter that is spread over the length of 6 meters. So we can apply a equivalent point load 4 kilonewton per meter times 6 meter, which is equal to 24 kilonewtons at a distance from 6 meter by 2, which is 3 meters from point A. Similarly, there is another point load of 18 kilonewtons, which is at 2 meters from point B and then from point C. Let's look at the static determinacy of this beam. Number of unknown reactions: 1, 2, 3, 4, and at point C 1, 2. So total number of unknown reactions or unknown forces are 6. We have 2 elements in the beam, so each element will have 3 number of equilibrium equations. So total number of equilibrium equation would be 3 times 2 equal to 6. Therefore, the degree of indeterminacy would be total number of unknown forces minus total number of equilibrium equation that we have. So this is 0. Then the beam is statically determinate. Now we can use or apply equation of equilibrium to solve this problem. Now let's look at this free body diagram. We can either start from section AC or start from section CB. What happens if we start from section CB and let's say we take summation of moment about B equal to 0, then vertical reaction VY and then horizontal reaction BX would be cancelled out. There's no any vertical or horizontal external load, so CX will be 0, but then moment at B and then the vertical force or shear force at CY, these are 2 unknowns. So there will be 2 unknowns, 1 equilibrium equation, so we cannot solve this from CB. Same case if we take moment about C equal to 0, these both forces will be cancelled out, BX is 0, but then there will still be 2 unknown forces. So it's better if we start from AC in this problem. So let's look at section AC. In section AC, let's take a moment, summation of all the moments at point C equal to 0, consider counterclockwise positive. Then if we take moment at point C equal to 0, what are the forces that are causing moment at this point? First is AY. The vertical reaction AY is causing clockwise moment, so negative AY times the moment arm 6 meter, and the external load 24 kilonewton is applying counterclockwise moment, so 24 kilonewton times the distance is 3 meters. So summation of all these forces would be equal to 0. Solving this, we get the value of AY to be 32, will be 12 kilonewtons, positive value, so we know that this is upward reaction as we assumed. Another equation of equilibrium, summation of all the forces in y direction to be 0 in section AC, considering all the upward reaction or upward forces to be positive. Starting from left, we have upward AY, external downward force of 24 kilonewtons, and then we assumed Cy to go down, so minus Cy equal to 0. We just calculated Ay to be 12 kilonewtons. So solving this, we can get Cy to be negative 12 kilonewtons. The negative indicates that we assume Cy to be vertically downwards, but it is actually with the same magnitude, 12 kilonewtons, vertically upward. Now we have two options: either continue to carry over this negative towards further calculations and keep this direction vertically downwards, but it would be easier if you correct it right away once we know. So this is 12 kilonewtons. This means this is incorrect. This would actually be going upward, Cy. So this equal and opposite will be transferred to section CB, which is Cy. There would not be any confusion when you calculate some moments at this section to carry over negative, because if you forget to carry over this negative toward that calculation, you might make a mistake. If we take summation of all the forces in x direction equal to 0, considering left to right positive, here we don't have any external applied load, so we can visually inspect that Cx would be equal to 0. Now moving on to section CB, we know Cx is 0. We calculated Cy to be 12 kilonewtons. So if we take moment at point B equal to 0, considering counterclockwise positive, Cy is applying counterclockwise, so 12 kilonewton of counterclockwise moment with moment arm 4 meters. The external load 18 kips is applying counterclockwise moment as well, so positive 18 kilonewtons with moment arm 2 meters, and there's a clockwise moment MB that we assumed, so negative MB. Summation of all these forces would be equal to 0. Upon solving this, we get moment at B, MB equal to 12 times 4 plus 18 times 2, which is 84 kilonewton meter. And our assumption that this force is clockwise is true because we got the positive value. Applying another equation of equilibrium, that is summation of forces, all the forces in vertical direction to be 0, considering upward force to be positive. We start from the point C. We have negative 12 kilonewton, that is Cy going downwards, negative 18 kilonewtons, which is acting downwards, and then vertical reaction upward, By equal to 0. If we solve this, we get the vertical reaction By would be equal to 30 kilonewtons, and our assumption upward force is true because we got the positive value. And finally, summation of all the forces in horizontal direction to be 0, considering left to right to be positive. We can visually inspect that there's no any external loads applied at this section as well, so Bx is going to be 0 too. So in summary, we have vertical reaction at A. We calculated this to be 12 kilonewtons. We have vertical reaction at B, which is 30 kilonewtons. There's no horizontal reaction at B. And then we have a clockwise moment MB, which is equal to 84 kilonewton meter.